Welcome to my channel Chemistry Drive with Nujmun Nissa. Students, you know that we have studied solid state previously also, but one topic was left, that is packing efficiency. So today we are going to start with packing efficiency because you will not find this packing efficiency anywhere in so detailed and so cleared manner. So I hope that you will just watch this video and try to cover all the important points that are related to packing efficiency. In your exam, questions may come related to packing efficiency, the whole derivation may come. So be very alert while studying packing efficiency. So let's start. So this is packing efficiency, it's the topic of solid state. So now the question arises, what is packing efficiency? It is the percentage of total space that is acquired in a unit cell by the constituent atoms, and these atoms or the particles, they may be ions, molecules or ions. So we can say that packing efficiency, it is the amount, it is the percentage of the space that is occupied by the molecules, ions or atoms. So packing efficiency we want to study, we are going to study in under three topics, that is CCP and HCP, then BCC, and then the last SCC, simple cubic lattice structures. What are the factors that affect packing efficiency? There are certain factors that determine the packing efficiency. Number one is, that is the number of atoms in a lattice structure. How many atoms are present in a lattice structure? The volume of a unit cell and the volume of atoms. So these are the factors that determine packing efficiency. So let's have a look on how to calculate the packing efficiency in CCP. So in the above diagram, what you are seeing is that there is a diagonal AC, and AB and BC are the edges of this cube. We are taking AB and BC equal to small a, and this AC we are taking it as B. So in this you can clearly see that B is equal to 4R. One radius, second, third and fourth. So in this way we can say that the value of AC is equal to B, and actually B is equal to 4R, that is 4 times of that of radius. So we are just considering this triangle A, B and C. Angle B is 90 degree. So we can say that AC is the hypotenuse. Then we are applying the Pythagoras theorem in it. So how we are going to apply Pythagoras theorem is, this is our hypotenuse. AC square is equal to AB square plus BC square. Then we know that according to Pythagoras theorem, hypotenuse, the square of hypotenuse equal to the sum of the square of its remaining sides. So we can say that B square is equal to A square plus A square. Why A square plus A square? Because these are the sides of the triangle, that both are equal, edges are equal, so we have put A here. So the value of B square has comes out equal to be 2A square. So if we are calculating it as B square is equal to 2A square, and we want to calculate the value of B, so the root will come on 2 and A will remain as it is after having square root. Now I have just previously I have told you that B is equal to 4R also. We are putting 4R equal to root 2A. After that we know that the total, how many spheres are there? In cubic closed pack there are 4 spheres, we all know, we have studied it earlier. So the volume of one sphere is 4 upon 3 pi r cube. So total volume will be of 4 spheres, it will be 4 into 4 upon 3 pi r cube. And what will be the total volume of cube? So for that we are according to the formula A cube, that is H cube. So in that case we will be putting it as 2 root 2 R cube. The value of A we have calculated from here like this. We have rationalized it. After rationalizing it we are getting it as, so now you come to know that the value of A has come out to be 2 root 2 R. So this is how we will be calculating the value of edge length by relating it with the radius. So now after putting these values, we can easily calculate packing efficiency. So the formula for it is the total volume of sphere upon total volume of cube into 100. Since it is a matter of percentage, so we know the volume of 4 spheres will be 4 into 4 upon 3 pi r cube, and the volume of 1 cube we have previously shown in the previous slide, 2 root 2 r cube. In this way we are going to calculate the packing efficiency of cubic closed packed structures will be 74%. So if you have any problem, you can comment me in this. Now the next one is body centered cubic structures. You know that in body centered cubic structures, one atom is at the center of BCC crystal. So by applying Pythagoras theorem in the triangle EFD, where is EFD? We can see E, F and D. Here you can say that there are two edges, this one A and this one, they both are equal. This value, its value is also equal to A. So applying Pythagoras theorem, we can calculate the value of B, as you know. After that, we can take the example of the triangle AFD. Now we are taking the triangle AF and D. This value is C, this is B and this is A. So on applying the formula, we will be calculating it as C is our hypotenuse. So C square is equal to A square plus B square. Now we are going to calculate, then B square is equal to B. The value of B is 2A. So we will be putting it as, that is C square is equal to 3A square. Then the value of C will come out to be root 3A. Now we know that the radius of each sphere is r. Back to the previous slide, we'll see that the value of C will be equal to 4r. One r here, the other one here, other one here, and in this way we can see the value of C will be equal to 4r. So we'll be equalizing these two values, and from here we'll be calculating the value of r. I hope the thing is clear to you. Now in BCC crystal, you know that there are 2 atoms per unit cell. So in that case, we'll be calculating the total volume of spheres will be 2 into 4 upon 3 pi r cube. The next one is the packing efficiency. So the total volume of the sphere upon total volume of cube into 100. So the total volume of sphere will be, since it has 2 spheres, so it will be 2 into 4 upon 3 pi r cube. Total volume of cube will be equal to, so the volume will comes out to be 68%. And the metals like chromium and iron, they will fall under BCC. Simple lattice structures. The last topic of it is simple lattice structures. You know that simple lattice structures have only one atom per unit cell. So we will say that the value of radius is equal to 2a. The total radius of these atoms will be equal to 2a. Since it has only one atom per unit cell, we know, so its packing efficiency is very easy to calculate. We'll put the total volume of sphere upon total volume of cube into 100. So the total volume of sphere will be 4 upon 3 pi r cube. Total volume of cube will be 8r. Okay. So in this way, we are going to calculate the value of it as 52.4%. Now we come to our last topic, that is importance of packing efficiency. Packing efficiency is very important for us. It represents the solid structure of the object. As far as we study the different properties of the different solids, we are going to know about the consistency of the structures, the density of the solid, and as well as the isotropic. Isotropic behavior of certain elements, we can see that when certain metals, they behave same in all the directions related to their properties, and we are considering them as isotropic, like glass and plastics. So with the help of packing efficiency, different attributes, we are going to study about the different solid structures, so related to packing efficiency. So the importance of packing efficiency is quite important in our daily lives. related to study of glass, metals and plastics. So with all this, we are going to conclude our topic. Thank you very much for watching my video, and keep watching my video, and don't forget to comment and subscribe.